discover the same pattern if we illustrate it out on a number line? To test that, let's start by illustrating out two similar problems. Positive 4 plus something gives me positive 6, and positive 4 minus something gives us positive 6 as well. Let's start with the addition problem. We're going to start at 0. Positive 4 is going to send us 4 places to the right. From there, we need to get to positive 6. That means we need to add more positive values to that. From positive 4 to positive 6, it's 2 more values, so positive 4 plus positive 2 gives me positive 6. Now what would that look like as a subtraction problem? Well, we would still start at 0, and positive 4 would still send me 4 places to the right. I still need to end up at positive 6. But subtraction can also mean the opposite of something. So I need this to be the opposite of what my value states. Since I need to go to the right, the opposite of that would be to the left. So I need to do the opposite of a negative. So I need to subtract negative 2. So positive 4 minus negative 2 is going to land me at positive 6. If we notice, the illustration on our number lines actually look identical to each other. If we compare our problems, the first value is the same in both. They both start with positive 4. The addition sign in the first problem is a subtraction sign in the second problem. Our second values are actually opposites of each other, positive 2 and negative 2. Despite that, our solutions come out to be the same. When we illustrate out subtracting problems, we can see that there's a distinct relationship between addition and subtraction. We're going to use those relationships to find an algorithm for subtracting with negatives. Let's start by illustrating out two similar problems on a chipboard. In our first problem, we're going to illustrate positive 9 minus something gives us positive 6. And in our second problem, we're going to illustrate positive 9 plus something gives us positive 6. Well, let's start with our subtraction problem. I have 9 black chips on the board because our black chips represent positive values. I need to have 6 black chips on the board, so I'm simply going to take away 3 of them. When I do, that leaves me with positive 6. So positive 9 minus positive 3 gives me positive 6. Now over here, I'm still starting with positive 9 chips, and I want the same result of positive 6 chips, but I need to do so by adding something to the board. In order to add to the board and lower its value, I'm going to use negative chips. Our red chips represent a negative 1. When I combine a negative 1 with a positive 1, the values cancel each other out, and together they're worth 0. By canceling out the value of 3 of my positive chips, I'm left with 6 positive chips that hold value. So positive 9 plus negative 3 gives me positive 6. Let's compare our two problems. In both of them, we start out with positive 9. Our subtraction sign in the first problem is an addition problem in the second, and the second values are the opposite of each other. In my first problem, I have a positive 3, and in my second value, I have a negative 3. However, both problems yield the same solution. We can put the pattern that we keep finding together into an algorithm for subtracting with negatives. As we've gone through our different examples, we've noticed that we always need to keep our first value the same. And then we don't actually wind up subtracting, but we actually wind up adding. So I change that subtraction sign to an addition sign. When I do that, I also need to use the opposite of the second value. And from there, I can follow my algorithm for adding with negatives. Well, let's try our algorithm out on a few examples. To start with, we have positive 10 minus negative 12. Well, our first value needs to stay the same. So positive 10 is still positive 10. From there, our subtraction sign changes to an addition sign. I then need to use the opposite of my second value. So instead of using negative 12, I'm going to use positive 12. And now I can follow my rule for adding with negatives. Since my signs match, I'm going to add like normal. So 10 plus 12 gives me 22. Since both my values are positive, my sum is also going to be positive. Positive 10 minus negative 12 is going to give me the solution of positive 22. Let's try another problem that has all negative values to start with. My first value is going to stay the same, so negative 8 will still be negative 8. My subtraction sign is going to change to an addition sign, and my negative 15 I'm going to use the opposite of, which would be positive 15. From there I can follow my rules for adding with negatives. Since my signs don't match, I'm actually going to need to take the difference of 15 and 8. The difference of 15 and 8 is 7. Since 15 has a greater absolute value than 8, I'm going to use the sign on the 15, so that's going to be a positive 7. So negative 8 minus negative 15 15 gives me a solution of positive 7. Down here, I'm going to start with negative 16, so my first value is going to stay the same. Again, my subtraction changes to an addition, and I'm going to want to take the opposite of my second value. So instead of positive 8, I'm going to have negative 8. From there, we can follow our rules for adding with negatives. Since our signs match, we can add our two values together. 16 plus 8 gives me 24. Since both my values are negative, my sum is also going to be negative. So negative 16 minus positive 8 gives me a solution of negative 24. On our last example, our positive 7 is going to stay the same. Our subtraction sign is going to change to an addition sign, and from there, I need to take the opposite of positive 12, which would be negative 12. Now I can follow my rules for adding with negatives. Since positive 7 and negative 12 don't have the same sign, I actually need to find their difference. The difference of 7 and 12 comes out to be 5. Since 12 has a greater absolute value than 7, I'm going to use my negative sign on the solution. So positive 7 minus positive 12 gives me a solution of negative 5.